Hello, Algebra 1 students. So this is going to be 10.8 part 2 or day 2. Okay, this is going to be called factoring using the grouping method. And if you did happen to watch 10.8 part 1, I know that video ran a little long. This one should be quite a bit shorter. Okay, so factoring out the greatest common factor. Sometimes the GCF is a quantity like x minus 3. So let's look at this first example here. We have x squared times x minus 3 plus 5 times x minus 3. So both of these have a factor of x minus 3, all right? And so we're used to factoring out a number or a variable, but we can also factor out a quantity, okay? So since both of these have that factor in common, greatest common factor, we can actually pull that out. So if we factor that out, we have x minus 3, and then what's left is x squared plus 5. Okay, that's where those are coming from. All right, and this method of factoring is going to be used whenever we have a polynomial that has 4 terms. So use when the polynomial has 4 terms. And basically this factoring by grouping, for the most part, is going to kind of be like taking out the greatest common factor twice. And we'll see what that means in this first example. All right, so we have 2x plus 6 plus ax plus 3a. So we're going to kind of break this apart. So we have a polynomial with 4 terms. We're going to kind of break it apart into almost kind of thinking about it as 2 binomials. Okay, so what we're going to do is find the greatest common factor of the first 2 terms. Okay, so the greatest common factor of the first 2 terms is just 2, and then we're left with x plus 3. Okay, so we take the sign from up here, we're adding, and then we look at the greatest common factor of the third and the fourth term. And in this one, the greatest common factor is a. Okay, if we divide each of those other terms by a, we have x plus 3. So notice how the very first example in the notes we did, okay, we kind of have a similar look here, okay? And again, remember we can factor out a quantity. So because both of these have a factor of x plus 3, we can factor that out, okay? So we're going to do x plus 3, factor that out, and we're left with 2 plus a. So we first group the 2 terms. That's what we did right here. Group those together. And then we factor out the greatest common factor of each of those kind of binomials. Like we separated the polynomial into 2 binomials, kind of. Factored out the greatest common factor of those, and then factored out the common quantity. Okay, so that's kind of the process of factoring by grouping. So let's look at another example here. So we have x cubed plus 3x squared minus 5x minus 15. Okay, again, this first step is going to be kind of breaking it up into 2 separate polynomials almost. And we're going to take the greatest common factor out of each of those. So if we look at x cubed plus 3x squared first, all right, the greatest common factor is going to be x squared. Okay, divide each of those terms by x squared, we just have x plus 3. All right. And now let's look at the third and the fourth terms. We have negative 5x minus 15. Okay, so the greatest common factor here is going to be negative 5. Negative 5. So we get x plus 3. So as long as you did your factoring correctly, these parentheses are going to be the same. Okay, what's inside each parenthesis will be the same. All right, and now the last step is going to be factoring out that common quantity. So that common quantity here is x plus 3. So we factor that out from each term, and we're left with x squared minus 5. So it's going to take the sign of whatever's in front of it. So if we're subtracting there, we're going to be subtracting down there too. All right, so let's move on to example number 3. So first step for this problem is the same as it was for the last few. We're going to kind of look at this break it apart into two different things. So that first part, the 2xy plus 3y, okay, the greatest common factor there is just y. Okay, and then we're just left with 2x plus 3. Okay, we're adding here. So the greatest common factor between 2x plus 3, okay, is just 1. We actually don't have the largest greatest common factor there is just 1. So we have 2x plus 3. Okay, notice how when we're doing this, these are always the same. Okay, that's not a coincidence. As long as we're doing it right, and we are in fact pulling out the greatest common factor, these are going to be the same. All right, last step is to factor out that common quantity. So the common quantity is 2x plus 3, and then we're just left with y plus 1. All right, last example, okay? Looks kind of messy. We're dealing with some bigger numbers here, but before we do factoring by grouping, we can actually take out the greatest common factor from this entire polynomial. So sometimes the entire expression has a greatest common factor. All right, and we can take that out before we try to factor by grouping. All right, so let's look at 42, 24, 63, 36. All right, and I encourage you, if you don't see it right away, even though it might be kind of tedious, all right, maybe list out some of the factors. All right, but if we do that, we're going to find that the greatest common factor here is just 3. Okay, so factoring out of 3, dividing each of those terms by 3, we're left with 14x cubed plus 8x squared plus 21x plus 12. All right, and now we can factor by grouping just what's inside that set of parentheses, so a little bit easier to work with here. All right, so I'm going to start with that 3. Okay, that 3 is not going anywhere. All right, and I'm going to actually use a bracket because I'm going to have parentheses inside here and I don't want to get confused. Again, I'm going to take a peek at these first two terms here and determine what the greatest common factor is. Okay, and the greatest common factor here, so the greatest common factor of 14 and 8 is 2. And then we take a look at the variables. The variable with the biggest exponent is x squared. So that's what we're going to put. So that's the greatest common factor. And then again, to find what's in the parentheses, we're going to divide each of those first two terms by our GCF. And when we do that, we're going to get 7x plus 4. All right. Now I'm going to take a look at the third and fourth term in my polynomial and find the greatest common factor there. So the greatest common factor, 21x and 12. So because 12 doesn't have a variable attached to it, I know it's just going to be a whole number, no variable. And it looks like the greatest common factor here is going to be 3, so positive 3. Okay, and again, if that's confusing, you don't know what's going on, make sure that we're listing all the factors out and then finding the biggest number that those two terms have in common. Okay, but we can also kind of use some educated guesses to figure out what that could be. All right. And so 21x divided by our GCF divided by 3 is going to be 7x, and then 12 divided by 3 is 4. All right, and I'm going to close my bracket because that's all inside parentheses. So notice again, as long as we factored out the greatest common factor, these two parentheses should have the same things in them. All right, and if that's the case, we can factor out that common quantity. So if we do that, we'll have 7x plus 4, and then we're left with the greatest common factors from each of those first, second, and third and fourth terms. That's going to be 2x squared plus 3. All right, and I didn't mention it, but remember we still have that 3 out front. We cannot forget that 3.